Good afternoon, I am Marina Martínez, and today I will be presenting effect of lactate on cardiac fibroblast activation and its implication for in situ cardiac regeneration. Well, the main objective behind this project is the fact that cardiovascular heart diseases are the leading cause of morbidity and mortality in the world. Among the different types, we are focusing on the aftermaths of myocardial infarction. When myocardial infarction occurs, the cardiomyocytes in that ischemic area die and therefore compromise the contractility of the heart. This leads to cardiac dysfunction and ultimately to heart failure. In this scenario, the only long-lasting treatment is heart transplantation, and that is why we are trying to develop alternative therapies that would promote heart regeneration and also repair. For this, we focus on lactate because it has been recently demonstrated to enhance cardiomyocyte proliferation and differentiation into a more immature state. Therefore, it has been proposed as a potential metabolic modulator for the activation of endogenous cardiac regeneration programs. Specifically, we study the effect of lactate on cardiac fibroblasts, since they are the key regulators during the remodeling process taking place after a myocardial infarction. As you can see in this figure, they can adopt a wide variety of phenotypes, including inflammatory, proliferative, and resting phenotypes. And specifically, we are wondering whether lactate has an effect on the activation of cardiac fibroblasts, which will correspond to these states highlighted in green. This is of special importance because if this state is sustained over time, we would be promoting fibrosis. Now the question is how we are going to do this. And basically, we are going to study the in vitro effect of lactate on primary human cardiac fibroblasts. For this, we have a control group in which the cells are cultured with the normal cell media, the treatment group in which we supplement lactate on the cell media, and then a positive control group in which we will be supplementing TFBeta1 in the media, which is a cytokine that has been widely reported to induce this differentiation into myofibroblasts. Regarding the results, we have seen that the cellular activity is boosted by both supplementation of exogenous lactate and TFBeta1 as expected. On the other hand, this TFBeta1 supplementation increases the cell number, but lactate does not increase the cell number. We wanted to further corroborate this by another method, and that is why we checked by immunostaining the expression of the nuclear protein Ki67. And we further confirmed that lactate did not affect cellular proliferation. Then we checked the total protein content and saw that it's not affected by lactate, whereas TFBeta1 supplementation increases this protein content. And more specifically, we wanted to look at the total collagen content, and we saw that lactate supplementation did not increase the collagen production, whereas TFBeta1 supplementation enhanced it. Then we wanted to check the contractility properties of human cardiac fibroblasts, and for this we did this collagen contraction path assay, and we saw that lactate and TFBeta1 supplementation did not affect the contractility properties of human cardiac fibroblasts. Later on, we checked the expression of Alphasmooth muscle actin, which is the hallmark of mature myofibroblasts, and we saw that lactate supplementation decreased the Alphasmooth muscle actin expression, therefore suggesting that we are kind of controlling this transition into myofibroblasts by supplementing lactate in the media. In a similar way, we also saw that the cultures treated with lactate displayed a slower migratory behavior compared to the control cultures. So as a summary, we can say that exogenous lactate supplementation reduces the expression of the main myofibroblast markers, delays the characteristic migratory profile of activated fibroblasts, and does not compromise the normal functioning of human cardiac fibroblasts. And as a conclusion, we want to highlight that exogenous lactate seems to prevent myofibroblast differentiation without compromising their activation and viability, and therefore could hamper sustained fibrosis in prospective clinical applications. Altogether, this study further supports the potential use of lactate for in situ cardiac regeneration treatments. Thank you all for your attention, and I'm here happy to answer any question that you may have.